Valérie and I'm a senior application scientist at CCG. In this tutorial, I'll show you the flexible alignment application, which aligns small molecules by maximizing steric and feature overlap and minimizing ligand strain energy. For example, if I have two small molecules which bind to the same target, but I don't have a co-crystal structure and I don't know the bioactive conformation, I can use flexible alignment to generate possible alignments of the small molecules to help deduce the structural requirements for biological activity. So in this tutorial, I'll show you the flexible alignment of two acetylcholinesterase inhibitors. Let's get started. So first, I'll click on the Open button on the right-hand side button bar. From here, I'll select the structure files for neostigmine and physostigmine, which are two known acetylcholinesterase inhibitors. As I click OK, the structures will get loaded into the main mo window. Now I can use the System Manager to change the rendering. For example, I'll select Stick Mode, and I'll color the carbon atoms by chain color. Now, neostigmine is colored in orange and physostigmine in pink. To run the flexible alignment application, I'll go to the Compute menu and select Flexible Alignment. In the Flexible Alignment panel, I can select either Flexible Mode, which enables all atom flexibility during the generation of molecular alignments, or the Rigid Body Mode, which uses conformations as is, exploring only rotations and translations of the molecules when generating molecular alignments. The second alignment mode can be useful when the bioactive conformations are known. Now in this case, I'll use the default flexible alignment mode, and I'll also use the stochastic conformational search option to sample conformations of the molecules when generating the molecular superpositions. Other options in the panel allow me to configure termination and output criteria and enable the calculation of force field charges. Additional options are found in the Settings panel, where the top section contains advanced options for the energy minimization and searching protocols, while the bottom section allows for customization of the similarity terms and weights used for scoring the alignments. In this example, I'll use all the defaults, except that I'll reduce the number of iterations to 20 for time purposes. And I'll go ahead and click OK to start the calculation. Now, as the flexible alignment application is running, we see two things happening simultaneously in the main mo window. The conformational space of the molecules is searched using the stochastic conformational searching, and alignment space of the two molecules is searched to yield optimal molecular alignments. As soon as the calculation is started, a new database viewer also opens up to show the output database. In here, we can see that the molecule field contains the actual alignment of the molecules. Additional fields reveal the different scoring terms for these alignments. Here, U is the average strain energy of the molecules in the alignment, and F is the similarity measure, where a more negative value indicates greater similarity, in other words, better alignment of features such as hydrogen bond donors, hydrogen bond acceptors, hydrophobic groups, and so on and so forth. S is the final alignment score, which is simply the sum of U and F. So the objective here is to minimize the ligand and strain energy, to maximize the similarity measure, which means the most negative value is the best. And ultimately, the most negative score, S, will be the best alignment. Now, once the calculation is finished, the database is automatically sorted by the S score, with the most negative alignment score at the very top, which is the best alignment. In addition, the best alignment is automatically loaded into the main mo window, and that's what we see here. Now, if we have a quick look at the alignment that was generated, we see a great superposition of the carbamate groups, a great alignment as well of the phenyl rings, and good steric overlap on this side of the molecule. Now, if we want to see more than just the top scoring alignment, we can hide this alignment from the System Manager and use the database browser to visualize additional alignments. This is particularly useful in cases like this here, where more than one of the top alignments actually has a very similar score. So this summarizes most flexible alignment application, which aligns small molecules by maximizing steric and feature overlap while also minimizing ligand strain energy. If you have any questions about this application, don't hesitate to send us an email at support@chemcom.com.